Hi everyone, in this video we're going to go through the notes for 5E, graphing logarithmic functions. So we've already looked at exponential functions, and log functions are basically the inverse of that. So what we have on the screen at the moment are three different types of log graphs, just different bases. So we've got log base 2, log base E, and log base 3. And you can see they do have common features. So they all have an asymptote along the y-axis. They go through the x-axis at 1, 0, and can you hear my dog in the background scratching? They at y equals 1, it's the value of their base. So what we've got, let me just highlight here on my pencil. Okay, so the key values here. All right, so what I was saying before is when y is 1, your x coordinate is a. So you can see there on our red graph, the base is 2, so being your value of a, so the point is 2, 1. Then for your log base e graph, you've got the point e1, and log base 3 graph goes through the point 3, 1. On this graph, we don't have x equals 1 over a, okay, but that is another key feature of the graph, or key value of the graph. And then we've got 1, 0 for all of them. So their x-intercept is through 1. Now, obviously, the function can undergo some transformations. So this is just your basic one. Now, if you're doing some mapping, you can use these points. So we've got the point 1a. So a is your base. So when I say base, it's the little number down the bottom. Just highlighting it there. Okay, so we've got 1a, negative 1, we've got 1, 0, and we've got a1. So if you want to do mapping with points, you can use those points. All right, so sometimes when you're sketching, you can sketch using points, or you can find your x-intercepts, use your asymptotes, etc. It's probably a good idea to understand how to do both. But when we're doing sketching in this video, we're just going to be sketching using the asymptote and the x and y intercepts in the shape of the graph, as opposed to mapping with these points. All right, so as I said before, the y-axis is your asymptote. So you've got an asymptote at x equals 0, which is your y-axis. Your maximal domain is r positive, so that means that your argument, let me just highlight with a different color, this number here, which is x, has to be positive. All right, my phone just rang, so I can't remember what I was just saying, but yeah, you've got your domain, and then your range can be any real value. Okay, so just remember that. Your domain will change though if you've got transformations, and your range could also change if you've got reflections. So just be mindful of that. And you can also have restrictions on your graphs as well. So with your base, if your base is greater than 1, then it's a strictly increasing log function. If a is between 0 and 1, then it's strictly decreasing. So it doesn't mean that strictly decreasing doesn't mean it's negative. It's just a decreasing function. All right, so graphing your log graph. So you've got to always, with any graph, you've got to have the right shape. So just make sure it's a nice curve. Log graphs are quite easy to draw. The features of, now if your graph was like this, so y equals log a mx minus n. Okay, it's got a vertical asymptote here. So if you've had some transformations, that's your vertical asymptote. Your implied domain, now because your asymptote has shifted, your domain is going to shift. So you've got n over m there, and you've got an x-intercept here. So that might help you if you're, I'm highlighting so many things here, if your graph is in this form. Whoops. Now, your transformations, you do read them slightly differently. So I'm going to write over here the transformations, and the letters I'm going to use aren't consistent with what we've done before, because usually we use a as a dilation factor, but in this case, a is your base. So I'm going to use C, letter C, to represent a dilation factor. And we've got log base A. Now I don't want to use M. Let me just think what I can use. B. X minus H plus K. Okay, so what I've done here, and it's important to note this part. Okay, if you're looking at transformations, your coefficient of X has to be 1. So you might have to take B out as a common factor to see the dilation factor. Okay, so what we've got here, so your value of C dilated by a factor of C from x-axis. And if it's negative, obviously it's reflected. So I might just do that here, reflected if negative. Sorry, I should say where it's reflected. So reflected along x-axis. Oh my God, can't write, sorry. I'm rushing because I'm writing so slowly. Along x-axis if negative. Okay, the B is a dilated by a factor of C, by a factor of, oops, not C, 1 over B from the y-axis. Oops, and then if B is negative, reflected along y-axis if negative. And then what else do we have? H is your horizontal translation. All right, so moving along your x-axis, and then K is your vertical translation. Okay, so quite similar to functions that we've done before. I've used C and B to represent your dilation factor because A is used as your base. Now your base A, it doesn't really affect your transformations. It's just the point. Well, yeah, I shouldn't say it doesn't affect it. We're not going to look at that just yet. We're going to just look at if we're going from a log graph, like a base E graph, log base E graph to a log base E with a dilation, you're going to have the same bases. All right, which would make sense when we do some examples. All right, so I'm going to not do an example here. Or, yeah, I'm not going to, yeah, I'll do an example here, sorry. All right, so I'm just going to write a function. So y, me rushing, making mistakes. Y equals log, and I might just do base E because you often see base E, 3x minus 2. Okay, so if you had a function like this, you can get your vertical asymptote. So we have an asymptote at x equals n over m. So in this case, our value of n is 2 and our value of m is 3. Domain is at n over m, so 2 over 3 to infinity. So 2 over 3 is not included because that's your asymptote. Actually, I probably should write that here, asymptote. God, my handwriting's terrible today. And an x-intercept at 1 plus n over m. So n is, what was that, 2? So 1 plus 2 is 3 over, let me just make sure that's right, 1 plus n, so 1 plus 2 over 3. Okay, so an x-intercept at 1. So make sure that's correct. 1 plus 2 is 3 over 3. Okay. So if I was to graph that, let's graph it, because I think it's always a good idea when you're looking at any functions to understand what the graph looks like. So you can't see this too well. Let me just move that over. All right, so y equals, now if you're using Desmos or your calculator, you can just do ln to represent your natural log. And we have 3x minus 2. Okay, so there's our x-intercept there at 1, 0. Now, on Desmos, it doesn't show the asymptote, but you can kind of see it's shifted there from compared to your natural log graph. Okay, so the blue is log base e of x, and then the red has been transformed. All right, so going back to here, all right, so you can see those features there, but if you're looking at transformations, it's very important to note, well, what's happening here? You can't read transformations in this form, so you do need to rewrite it, and I'll rewrite it down here as y equals log base e, and take out whatever the coefficient of x is, take it out as a common factor. Whoops. All right, so I've taken 3 out as a common factor, well, as a factor. So that leaves me with minus 2 over 3. Okay, because when I expand that, I get 3x minus 2. Now, this is where you can see, all right, here we've got a dilation factor of 1/3 from the y-axis. This part here, we've shifted to the right 2 over 3 units. So if you think about your asymptote, your original asymptote, if I go back to our graph, was the y-axis. It's now shifted across 2/3. Okay, so 2 over 3. And they're your transformation. So we've gone to the right 2/3 and we've dilated by a factor of 1 over 3, not 3, 1 over 3 from the y-axis. Okay, so when you're looking at any transformations, or even if you're graphing, reading it from here, you got to be very careful to have it in this form, okay, as opposed to this form up here. So if it was like that, you can go ahead and use those values of m and n, but I think it's probably easier to get it in this form here. Okay, down here what I've written in blue. All right, so when we're looking at, well, let's skip all this for now. Let's have a look at some graphing. Okay, so when we're graphing these, we don't really need to look at the transformations. We can just do your x-intercept, your y-intercept, and your asymptote. All right, so for this first one, what we can see, hopefully you're familiar enough with transformations now. It doesn't matter that it's a log graph, that what we have here is +3, and we've got -2. So what the graph of y equals log base e of x has done, it's shifted to the left 3, or 3 units in the negative direction, and it's gone down 2. Okay, so that +3 and the -2, it's the same as if it was a parabola. But when we're sketching, it's probably a good idea just to draw your asymptote and then plot your x-intercept and your y-intercept. So that's what we're going to do. All right, so I'm going to put my axes on. Now, your asymptote before was the y-axis. It's shifted to the left 3, so let's put that in. So -3. Now, remember, when you're sketching, you can put your asymptotes in pen, but your sketching should be in pencil, just in case you make a mistake with your curving. Your curve. All right, so your x-intercept, just like with any other function, we let y equal 0. So we're going to have 0 equals log base e, x +3 minus 2. So we're just going to quickly solve that for x. All right, so we need to leave it in exact form unless a question specifies that you can approximate, so you can put it to decimal places. So when we sketch this in a sec, we'll look at what the approximate value of that is. All right, so for your y-intercept, we let x equal 0. So we're at y equals log e 3 minus 2. So your 2 points, your x-intercept, if we're doing the coordinates, which you should do, right, there's the coordinates of your x-intercept and then your y-intercept. Okay, so when we're plotting that, I might just quickly plot it because I know when we did this in class where the points roughly are. So this one here, remember to write the coordinates. And 0. All right, so when you're drawing your curve, oh, I'm not going to do it in, I'll do it in blue. Okay, so when I did this in class, it was terrible. So we want to have a curve happening, quite good, and we don't go over that asymptote. Okay, so this might be a little bit disjointed because of our scale. So let's sketch it on here. What was it? X plus 3 minus 2. Okay, so you can see, I just move this over. I wonder if I can make that wider. No, I don't think I can. You see your red graph. All right, we've got a y-intercept there at negative 0.901 and a y-intercept, x-intercept there. So that's your approximate values, and you can kind of see your asymptote. Even though it hasn't been drawn on there, it is at negative 3. All right, moving to the next one. So for question B, I can see that negative means it's been reflected along the x-axis. The 2 means there's been a dilation factor. And then the x plus 1, so the plus 1 means we've gone to the left 1. So even though we're not using transformations to sketch this, it's probably still a good idea to think about, well, what has happened to everything? All right, so your asymptote, actually let's put our, sketch our axes first. All right, then we'll put our asymptote in green. So it's gone to negative 1. And I'm just going to label that as x equals negative 1. All right, and now we've got to find our x-intercept and our y-intercept. So x-intercept, let y equal 0. So we're going to have negative 2 log e x plus 1 equals 0. We can divide both sides by negative 2. So e to the power of 0 equals x plus 1. So e to the power of 0 is 1, so x is equal to 0. So our x-intercept is 0, 0. When our x-intercept is 0, 0, our y-intercept is also 0, 0. So we're going through the origin there, and we can just sketch our graph. Oh, look at that, that's perfect. Now, if you wanted to do another point on the graph, you can say, all right, let's let x equal something. And let it equal 1. When x equals 1, y is equal to negative 2 log e 1 plus 1, which is 2. And if we're sketching that, let me just go here. What was it? Negative 2 log x plus 1 at, I don't remember. Awesome. Oh, I knew I drew it incorrectly as soon as I got that value. It's a reflected graph. Oh, glad I went to sketch it. Okay, it's been reflected, which I forgot to do. Okay, so I missed that. Silly me. All right, so that's why you do it in pencil. I was wondering why I had a negative value here, but on my graph it wasn't going to fit. Okay, so we're going to just reflect that in the x-axis. So it looks something like that. So at x equals 1, so we'll just draw this point here. So the coordinates of that are 1, -2, log e of 2. And if I go back to my graph, you can see it's roughly there. Okay, -1.386. Now, if you wanted to do a point of intersection, so you can see there's a point of intersection there, you just let their graphs equal each other. All right, let's have a look at the next one. So we're not going to do every single one. I might just graph it to show you on Desmos to show you, but we'll talk about the transformations first. So for question C, we have got a reflection. So we've got a negative x, so it's being reflected along the y-axis. So let's have a quick look at that. So we have our natural log graph there. So we've got negative x, so you can see how it's been reflected. All right, so you would continue to do an asymptote along the y-axis, so x equals 0, and then substituting in x equals 0 to get your, actually, there is no y-intercept because it's your asymptote. So to get your no y-intercept because it's an asymptote. So to get your x-intercept, let y equal 0, and you can see it's there. All right, I did want to move on to some hardware. All right, let's look at D. So D, if we're looking at transformations, have a look at your bracket. Okay, so the coefficient of x is not +1. So I'm going to rewrite that. That is equal to log base 10. And I'm going to take that negative out. And then we're going to have x plus 5 inside, then plus 2. So what I can see is we've had a reflection along the y-axis, and it's been shifted to the right 5, and it's shifted up 2. Okay, so let's have a look at our graph. Okay, so it's, if you think of your asymptote, which was at x equals 0, it's now at x equals -5. Your your x-intercept has also changed. It's become now -6, 0, which you can calculate if you let y equal 0. And clearly there's no y-intercept because your asymptote is at x equals -5. So when we're sketching it, first of all, think, all right, what's happening to my asymptote? It's shifted across to 5, but my graph has been reflected. So I'm not going to have any y-intercept. Sorry, I'm getting distracted by my son moving around. All right, so we know there's not going to be any asymptote, but let's just say we didn't know that. So let's have a look. All right, let's find the y-intercept. Let x equal 0. And you can substitute it into either one. They equal the same thing. So when I let x equal 0, I'm left with y equals log base 10 of -0 minus 5. So just minus 5 plus 2. Your argument cannot be negative. So therefore, you should say, well, that can't exist. So what is actually happening here? Oh, my asymptote is at -5, which is what we knew. But it's been reflected. That's why we don't have a y-intercept. All right, we do have an x-intercept, so we can work that out. We knew it in the graph I showed you on Desmos that it was at 6, but let's calculate it. Let y equal 0. Okay, so we've got log base 10, -x minus 5 plus 2 equals 0. I'll just make sure I've written that down. Sorry, I'm getting really distracted by my son. Let's continue on. Bring that -2 over. Let's make sure I've done that all correctly. All right, so 10 to the power of -2 is equal to -x minus 5. So 10 to the -2 is 1 over. All right, I just realized that I didn't type the whole function in. I was like, why am I not getting -6? Because I've got the +2 on there. So when I typed it in before, I didn't have the whole function. I've got the +2 on the end. Okay, so your x-intercept is actually not -6. You can see it's there at -5.01, which is good because that's where I was heading. So I did have to pause because I'm like, this isn't going to equal 6, -6. All right, so 10 to the power of -2 is 1 over 100. And then we've got -x minus 5. So x is equal to -5. Let me just quickly check. Minus, now, you can leave it as a fraction. I'm going to do it as a decimal. So 1 hundredths is 0.01. So x is equal to -5.01. Which is just, I guess, very close there. Okay, so when we go to graph it, let's make sure I'm going to graph it correctly. All right, so we're going to be quite close to the asymptote, oh, a bit wonky, and then we're going to curve. So for this one, we've got an asymptote that's shifted. It's x equals -5. We don't have a y-intercept because of that asymptote and the reflection. We do have an x-intercept, which is at -5.010. And it's okay to write it as a decimal because that is actually its exact value. It's not a terminating decimal. I mean, it's not a irrational number. Okay, it's a terminating decimal. We haven't rounded it. All right, let's have a look at just rewriting a few others, and then I'll just leave you to do these on your own. So we've got y equals log base 2. And I'm going to take that negative out. So we're left with x minus 2. And we don't forget the -6. Okay, so it's had a reflection along the y-axis, shifted to the right 2 and down 6. So when you're sketching it, your asymptote has shifted to the right 2. It's been reflected along the y-axis, so it is going to have a y-intercept, and it's gone down 6. So it's going to have a y-intercept and obviously an x-intercept as well. All right, with question F, let's just rewrite this one. So we've got y equals negative log base e. Now we're going to take that coefficient of x out, so -2, and then we're left with -3 on 2. Have to think about that one. Just double check. So yep, and that's good. All right, so we've got 2 reflections. It's been reflected in the x-axis and the y-axis. All right, so those 2 negatives, we've had 2 reflections. We might actually have a look at this one on Desmos. And it's shifted to the right, 3 on 2. Okay, so think about when it's reflected and then reflected again, and it's shifted to the right, 3 on 2. Do we have a y-intercept? Now you can go ahead and try to calculate it if you're unsure. Just always substitute it back in because you want to make sure whatever is inside this bracket is positive. So not x itself, but what is inside that bracket has to be positive. All right, let's sketch this one on Desmos. So negative log, and I can't remember what it was, 3 minus 2x. Okay, so you can see it's been reflected and then reflected again. The asymptote is at, what was it, 2 on 3. No, 3 on 2, sorry. So you can see it's clearly there. 1/3. 1 and 1/3. No, 1.5. Oh my gosh. I shouldn't be doing these when I'm tired. 1.5. And then we do have a x-intercept and we do have a y-intercept. Okay, so you would need to go ahead and calculate them, even though you can see it's 1, 0. And there we've got the approximate answer, but go ahead and calculate the exact value for that y-intercept. All right, the last part of these notes, this can be quite confusing. So we're going to cover this question, but it's such a small part of the course. So if it's a little bit hard to understand, there is an example earlier on as well. So I put an example here. All right, so find a transformation that takes the graph of y equals 2 to the power of x to the graph of y equals e to the power of x. So what has happened in this example, and this is how we're going to answer the question as well, that e is equal to 2 to the power of log base e, because this cancels out, all right, and we're just left with e. So that means e to the power of x, what we can do is also put that in, and that becomes our part of our dilation factor. Okay, so you can see, oops, what am I doing? Highlighted the wrong part. This part here. That becomes our dilation factor. Because if you remember back to when we did exponentials, all right, looking at the dilation factor from the y-axis, okay, we're actually always looking at this value here. We didn't look at it in terms of logs, we just looked at it in terms of integers. Okay, so just normal numbers, not logs. But log base 2 of e is a number. Okay, so even though it, we don't have digits there, it is an actual number. So when you're looking at a dilation factor going from y equals e to the power of x to y equals 2 to the power of x, you just follow this working out, and it's a dilation factor of 1 over log base 2 of e from the y-axis. So let's do the other question, which is kind of very similar. We just switch them around. All right, so we've got find the transformation that takes the graph of e to the power of x to the graph of y equals 2 to the power of x. All right, so 2 to the power of x is equal to e to the power of log base e. So remember, that is 1 to x. Okay, so we haven't actually changed anything here. All right, all we've done is said, okay, what is happening? What can we do to find the transformation? So whatever the coefficient of x is, so in this case, it's log base e of 2, that becomes your transformation. Not your transformation, sorry, your dilation factor. So we've been dilated by factor 1 over log base e of 2 from the y-axis. Now, just to re-jog your memory, I'm going to go back to where we did the exponentials. Which is here, I think. Okay, yes it is. So I'll just get my highlighter. Okay, so when, scroll up. Here. Okay, so you can see here the number, the coefficient of x, which in this case is b. Okay, so b just represents a number, and the question which we just did, it was log base e of 2, I think it was. All right, so your dilation is a factor of 1 over b from the y-axis. Okay, so that's the relationship between the coefficient of x and your dilation. All right, I'm going to leave that there. Make sure you do those other graphs. Let me just scroll through. Okay, so the 2 or 3 I didn't do. Make sure you do them by hand. And hopefully this video has helped. And then we can move on to 5F. All right, girls, bye.